Hi friends, welcome to episode 8 of Beginner's Answers for Heat Transfer. In this video, we are discussing about the post-processing operations of our thermal analysis. In the previous videos, we discussed how to set up the analysis, set up the structure and solve the solution. So let's start. In Apdl main menu, we have already covered the preferences, preprocessor and solutions. Next we are going into general post-processing. So it means we are viewing the results that we solved for. So let's go into general post-processing, and now first of all we are going to plot the results. So go to plot results, contour plots. There is two types of solution, nodal solution and element solution. As we discussed earlier, when we meshed, we divided the solid into different elements. Here basically rectangular cuboids, and the vertices of each element is called a node. So we can either display the results at nodes or display the results with each element. So if we go to nodal solution, degree of freedom solution, click on nodal temperature and click OK, we will get a gradient across the structure. So if you zoom in, we can see that at the edge where we gave 16 degrees Celsius, that is 289.15 Kelvin, is the hottest side, and the edge with that we gave 279.15 or 60 degrees Celsius is the coldest. So the solution is logically correct. So now we are going to make sure that the thermal flux that we calculated analytically is matching with the thermal flux that we are getting through ANSYS analysis. So go to nodal solution, click on thermal flux. So we can use any axis that we need, but let's go with the thermal flux vector. So per our calculation, there should not be any thermal flux in the x and y direction, but there will be 20 watts per meter square thermal flux in the z direction. So let's go click thermal flux vector sum and click OK. So see here the value is a constant, that's why the color is a single color, and here we can see that the thermal flux that we calculated is correct, 20. And even if you go into element solution, we cannot do the degree of freedom solution because degree of freedom is related to the nodes, but we can calculate the thermal flux. So thermal flux, go to thermal flux, click on thermal flux vector sum, click OK. So we get the same value. Now we need to list the results so that we can get values in a more accurate way. So go to list results, go to nodal solutions, click on thermal flux, click on thermal flux vector sum, click OK. So as we can see, there is thermal flux in the x and y direction. So if you look closely, it is negative 0.4 to the 10 to the minus 14. That is a very small value, and if we sum that one, it will come to 20 itself. So basically in the x and y direction, it is very small, a negligible amount of thermal flux is there, but the z direction is our main concern and it is correct. Negative 20 is the value. The next thing I want to discuss with you is about the result viewer. So go to result viewer. So it will open a new window, and in here select what we want, like say nodal temperature, and we need the contour plot. So select that and ask it to plot the solution. So it is plotted here. Now if you want to see the temperature at a specific location, click on query results and click at any position, and it will automatically show the temperature at that point. It will also show the temperature here also, 282.483 Kelvin, and if you click OK, it will be displayed there. The location is not good, but it is displayed there. And once we close the window, we can see that the annotation that we set at result viewer is still there. So if you are making a PDF or something like that for a presentation, we can use this as a tool to display a value at a particular position. The next thing is an important thing, path operations. So in path operation, we are going to create a path across the structure and display the values accordingly. So let me show it in action. So let's go to define path. So they will ask how to define. So I am going to plot all the elements for now, and I am going to define a path based on nodes. So I click on nodes and I select this node and this node. So I'm actually, that's not the node I meant, so I deselect it and select this node. Okay, and so here you can see two nodes were selected, and basically I'm saying that I'm creating a path in between this first node and this second node, and click on OK, and we can give a path name. So say across and click OK. So that path named across was created, and then we can do is most probably there is only one path right now, but if you're creating more than one path, we can recall paths. So go into recall paths and select across. If we have more than one path, all the paths that we want will be displayed over here, and click OK. Then we can go into plot paths. So when we click on that, it will show all the paths that we have already defined in the structure. So here we can see I have defined a path across between these two nodes. Now plot path item, so click on that. We can either plot on a graph or geometry. So I am first of all going to plot on a graph, so click on that, and here there's a lot of options. So click on temperature, click OK. So it's a graph between those two nodes. So we can see that at one end it is 289.15 and it is linearly decreasing across. So on the outside of the window pane it is 289.15, on the inside is 279.15, and it is linear across the window width. Now let's plot the same thing onto the geometry. So click on geometry. We need the temperature, and we can select do we need to show according to the nodes or not. So I'm going to show with nodes, and see all the nodes are there, and we selected these two nodes, and the gradient of temperature between these two nodes will be shown here. We learned how to view the results, so now we have to learn how to save the results. So let me first plot the elements and resize it. Okay, now whenever we want to plot something or take a snapshot of something that is on the screen, on the editing pane here, what we can do is, so say we are going to plot the nodal temperature contour plot. So click OK. So this is what we want. So we can go to plot controls, write meta file, and there is two options, standard color and invert white or black. So in standard color means the background will be black and the structure that we created with the results will be in front of it. In invert white, the background will be white and the structure with the results that we created will be in front of it. Usually it is good to go with white, so let me go with that, and it will ask where to save, so I will save it here. And if I go to that file that we just saved, it is over here. Now the next step is to create an animation of the results. So for that, go to plot controls, animate, deform results. So I am going to get the results for degree of freedom solutions for temperature, and we can set the number of frames. So I am setting it to 30 and delay time as 0.2 and click OK. So it will be created and start playing automatically. And the thing is, when we created the animation, a file was created in our directory which has the video file of this animation. So let's go check it out. here is the project FEA video file. Clicking on that, and here is the video. In the next video we will be discussing about a simplification process for the same problem, which will make the problem more efficient. So let's go to that. Thank you.